In this video, we'll be talking about a history of databases, which is really a history of hardware and the kind of ideas on how to build better databases to serve the needs of the then state-of-the-art technology. So we'll start with by talking about punch cards. So these were around well before I was even born. These were ways to read information into a computer by basically punching holes in these little cards. Obviously, you can't store a whole lot of information on each punch card, and they're primarily used to feed information into a computer. You'd write out your programs through these holes on punch cards, feed them into the computer. However, obviously, not a lot of data can be stored on them, and the way these punch cards work is you basically read them one after the other. You basically bring in your program. It's a big stack of punch cards, and you feed them into the computer. It would process the data. You'd also load all of your data into the computer through the same means. Then data was stored in files, like literal paper files, that you read from beginning to end. And this is kind of how we originally started talking about, well, how do we store data in a computer as a big series of data, a big series of characters from beginning to end. Later on, there is the development of disk drums, which allow for the storage of information on basically little magnetic bits onto these rotating drums. They form both the central memory. This is really how the computer stored its own processes, its own programs, its own data while the program is running, as well as secondary storage, which means once the computer gets turned off, that data still stays there and present. However, disk drums, as you can see above, had very limited amounts of memory, and so most of the time computers were really meant to read in information, process it, and then output the information as opposed to holding it in memory to do much work with it there. Later on, the development of magnetic tape, which is basically the same thing as cassette tapes, except a little bit altered to be more useful for computers, was developed, and this allowed for the ability for computers to store large amounts of information that would persist for a fairly long time. They'd have huge rooms with thousands of these reels that was constantly writing and reading from. Now, the problem with magnetic tape is you can only really read or write from it at one particular point, and if you have to read data that's at some other part of the tape, you basically have to spin it around to get the data that you need under your read head so that you can actually work with it. And so it means that you can store a lot of data because tape is very thin and you can reel it up very tightly. However, it has very low latency. Very high latency. It takes a really long time to get to any particular piece of data unless it happens to be very close to the read head. So this means that you can store lots of information, but it's often very slow to get to any particular part. Now, this changed with the development of hard disks. So hard disks are actually very similar to disk drums, except instead of having this big column that you turn, you have these little platters that you spin, but you write bits on them in much the same way. And so the nice thing about having all of these little platters, it means that you can more easily jump to different parts of your data. You just need to move this little arm to read from one part of the spinning disk to another part of the spinning disk. It still has some more latency, but much less than magnetic disks. And even though hard disks often didn't have anywhere near the same storage capacity, you couldn't fit nearly as many bytes in the same amount of space, you were able to get to those bytes faster, which allows you to do a lot more interesting sorts of data analysis, as well as store your data in much smarter ways to allow for much faster retrieval. Now, the technology that's likely in all of your guys' computers at this point is solid-state drives, which are basically random access memory. It's the same sort of just storing bits and bytes and logic gates that you have in your RAM, except slightly optimized so that it can hold much larger amounts of data at the small sacrifice of a bit of speed. However, solid-state drives are much, much faster than hard drives in almost all respect, and nowadays they're becoming increasingly dense such that they can hold as much information as hard drives, meaning that hard drives really don't have a place in kind of current technology means unless you're really trying to save money. Okay, so those are the kind of storage technologies that we've gone through to come here. Let's talk a little bit about why do we call a database at all? And it actually comes from the fact that the first database was actually a military complex. It was actually a real military base that was developed by the SAGE program, which is the idea of it would accumulate all of the information, all of the data from various different centers, from radar dishes, from flights, from radio towers, that would all get funneled into one place where it would be processed and then distributed to whoever needs that information. It was the idea of like a central clearinghouse for information developed using kind of Cold War technologies. Now, this was a rather complicated facility. It takes in a lot of different information in a lot of different forms, and it's meant to process that into some form that you can say, hey, there is a nuke coming from Russia over here, or there are these fighters that need to land over here, and it can be distributed, that information. Now, one of the big innovations here is this was a much more complex project than really any of the other systems were of the time. And it was also one really big difference is this was meant to be a computer used in real time. It's meant to take in information as soon as it comes in, process it, and give that information out as quickly as possible. Obviously, if you're trying to do military operations, speed is often of the essence. And so, in addition to just taking in information, processing, responding it, it was actually used by many different consumers of that data. So a lot of different types of data were coming in, and a lot of different sorts of people were trying to use that information. So it was really important that it was able to change the representation of that information into different ways. And so this actually popularized the term of database, referring to being able to store your data in a way that many different people can use that data for different purposes. So let's talk about how databases kind of changed how people used computers, especially in corporate contexts. So it used to be here on the left that the kind of plan for how do you organize information is at the very bottom you have a bunch of different people who each have their own special parts of the information, and they would pass that up to management, and management would take these information from a dozen different separate sources and then use that to decide, okay, what do we actually need to do, in terms of management decisions. However, that kind of changed with the idea of, whoa, actually, maybe the better thing to do is instead of having a dozen different places, some people are in charge of payroll, some people in charge of marketing, some people in charge of logistics. Instead, you condense all of that information into a single source, a single database, and you have many different people that work with that same data because they may need information from different sources. All right, and the last bit I want to talk about in this video is talking about kind of the evolution of different ways of accessing data and using data on a computer. So in the very beginning, way back in the Penchcord era, and still today, we still have files today, you have the idea of file-based storage. Basically, the idea is you store all of your data in one file. Now, what is a file? Well, that depends a little bit, but it's usually a string of characters or bytes that represents all of the data that you want to keep track of. Now, usually you read files from beginning to end with some ability to jump perhaps to parts of the middle of the file. So there's various different ways you can access the file: sequential, going from beginning to end; index, jumping to particular places; random access, meaning that you have ways to go, I want to jump to the middle and see if my information is here or one way or the other. However, big problems with using file-based storage is really, in order to do anything of note with these files, you need to be able to do some bit of programming, which is often not what you want your managers and things like that to be able to do. Another big problem is each file has its own kind of formatting, and so different programs would basically be working with their own versions of the data. Another big problem is, especially if you have interactions among your data where one particular person is working on multiple projects, but each project has multiple people working on it, those sorts of interactions, it means that you often have a lot of duplicated data. You'll see one person's name appear many places in the file, and it means that if something goes wrong, if somebody changes their name or something, you have to change a large part of the file. It also means that your files are much bigger than they necessarily have to be to hold the same information. And then you also have a lot of costs associated with maintainability. So if things change, you have to make sure that you change all of the instances of what that change might have caused. And you also have to worry a lot about security. So for instance, for most file-based systems, basically, if you have access to the file, you have access to all of the data. You can't just say, oh, this part of the file can be read by the CEO, and this part of the file can be read by the programmers, and so forth. And so it's a lot more crude in terms of if you want to say, this data should be read-only, this data should be write-only, or write-only data doesn't really make much sense, but only able to be written by certain users. So what tended to change is over time, people started to organize their data in a more hierarchical way, with the idea of, okay, instead of having all of your data in a single file, you have this hierarchy of parents and children holding more specialized information and thus far. And so what this does is it means that instead of having just one big file, you have to find the particular file or files that contain the information you want. It allows for a lot more efficient searching. It allows for less redundancy of data because you don't need to copy things to every particular element. You can structure it more better. At least for some data independence, meaning, hey, if you need to adjust the personnel people, you only have to adjust those files instead of having to have write permission on the entire big database. Now, problems is this is a lot more complex than just a single file, meaning once again, it becomes harder to write programs that work with the data in this accurately. This also can't handle certain types of relationship, for instance, that many-to-many relationships. We'll talk about this more later, but the idea of, say, if there are many users or many employees on a particular project, but many projects that each employee works on, this doesn't give you a nice way to represent that part of information. The other problem is it also lacks some structural independence, meaning if you change one part of the database here, a lot of programs and other applications of the database may not be expecting that change and can lead to them not working as well. So it becomes very hard to change things. In response to some of these criticisms, there was a move towards a network data model or sometimes a graph data model. The way that you represent this is basically each vertex, each node in this graph represents some class of data, and it has relationships, it has edges that point to other parts of the data. And so in this example, we have a store. Then you can have many examples of the store, but they all fall into this particular category. And for each store, you can find particular customers of that store, particular employees of that store. And each of those have relationships with particular orders. Now, the nice thing about this graph is that now you can handle a lot of those many-to-many relationships. But then everything gets so much messier in terms of it becomes really hard to extract the data that you need. It becomes very hard to modify this database, to change the structure of the database in a way that doesn't violate assumptions that other programs you wrote have made. And so this, for the most part, has gone out of date in terms of what is really, when people talk about databases, they're really talking about this form of database. Now, what is this? These are relational databases. When you talk about SQL is a language that's meant to work with relational databases. We'll be spending a good half of, actually a bit more than half of the class talking specifically about these databases, so I won't spend a lot of time talking about them here. But the idea is that you have many tables with rows and columns, and each table has a very organized set of data that's within them, and these columns are allowed to reference other columns in the database. And so what you have is an instance of a database which has basically all of the data. And then this schema represents how those different bits of the data are connected to each other, what types are allowed. We'll be talking about this more in a little bit. Now, some of the advantages is you can emphasize a lot of control and a lot of structure over how everything is laid out. You can do things like say, hey, this particular table is only allowed to be accessed by particular people. It's also able to represent many different types of data. It's able to represent those many-to-many relationships, and we'll go through that through the course of this semester. Now, what are some of the problems? Well, with this sort of database, there's a lot of complexity in terms of building these database systems. If part of your database management system fails, if you have some sort of corruption, it can lead to a lot of problems for the entire database. But a lot of these problems are alleviated by really working, instead of writing your own, I'm going to write my software that will build the database and work with database directly. Instead, usually you say, I'm going to use a particular library, a particular software that can handle the database well, and I'm just going to ask that database software to do what it needs to do. And now lastly, there's also another type of database that is really going out of style of late, which is called object-oriented databases. And this is very similar to the relational databases, but instead of just storing simple types like strings and numbers, instead you actually store objects like class, object, and programming. And now these objects have attributes, they have fields, they can also inherit from other objects, and they can hold behavior and things like that. So the really nice thing about object-oriented databases is you can store very complex data in your database that can have a lot of relationships with other parts of the database. You can store behavior instead of just text. However, this is a really hard model to do a lot with. Most databases don't need kind of all of the power that object-oriented databases have. And the other problem is these objects are really programming things. And so for the most part, these object-oriented programs work with a specific language and a specific API. And so it becomes actually quite a lot harder to work with a particular object-oriented database in a language that isn't really meant for that database. And so you have a lot more lock-in in terms of how you're able to actually work with that database. Okay, so that wraps up basically all of the history that you really need to know for this class. And so I'll just give one multiple choice question here. So why was the development of hard disks important to databases? And I'll give you a couple seconds to think this through. You can pause here if you like. Okay, so let's go through. Now, hard disks didn't actually have a larger storage capacity. Magnetic disks, or magnetic tape, has a much larger storage capacity than hard disks. Now, block segmentation, now we're not even going to really talk about those sort of low-level OS sort of things, so that really wasn't important. But the big thing that was important for hard disks is this low latency. It became much faster to access particular parts of information. Now, we'll talk about why that's important later, but it means that you can fairly quickly jump to particular parts of, say, your database instead of having to read from the beginning of your database to the end of the database. And now, if you like the hum, that's entirely up to you.